Today what we're going to be talking about is direct, inverse, and joint variation. And what we're talking about here is a relationship between groups of numbers. Uh, there are different ways that numbers can relate to one another, and specifically we want to talk about direct and inverse. If two sets of numbers have a direct relationship, that basically means that they're growing in the same way or shrinking in the same way. So as one set of values is getting larger, then the other set of values is also getting larger. Um, an inverse relationship would be if they were going in the opposite direction. So as one set of numbers is getting larger, the other set of numbers is getting smaller. So that's the first thing we want to realize. A direct relationship is when both sets of numbers are moving in the same direction. So if the x numbers are getting larger, then the y numbers are getting larger. An inverse relationship is when they're moving in the opposite direction. So as one set of numbers is getting larger, then the other set of numbers is getting smaller. Some situations in life where you might see this, a direct relationship. As the number of hours that you work increases, the amount of money that you make also increases, hopefully, if you have a good job. Inverse relationship would be something like in science. You see this one in science a lot. As the pressure on a gas increases, then its volume decreases because it's pushing in on it. Its volume is getting smaller. So as the pressure increases, the volume decreases. That kind of thing. So this would be an inverse relationship, and this would be a direct relationship. How can you tell whether sets of numbers have an inverse relationship or a direct relationship? So let's talk about what their actual equations look like, okay? For a direct relationship is always y is equal to k times x. And for an inverse relationship, y is equal to k divided by x. What is k? Let's talk about k for a second. K is the constant of variation. It is some number. As you can imagine, everything in the world doesn't have the same number there. Everything is in a different type of relationship, even within the same rule, like the rule about as pressure increases, volume decreases with gases. Well, that's different for every single type of gas. Oxygen doesn't behave the same way as helium. You know, they have different amounts of pressure that they can take and the effect that it has on its volume. So the constant of variation is what makes it unique, because otherwise we'd have the same equations over and over and over and over again. So this is what makes each situation unique. It's always going to be some constant, some number, all right? And that's your constant of variation. That's your relationship, all right? And so in a direct relationship, it's that number times the first number to give us the second number. You know, we make a little XY table. K is what's being multiplied every single time. It's the common factor, so to speak, between all of the numbers. In an inverse relationship, it's being divided by that x number, by that first number. And so it is also still that common ratio between the two numbers. And so k is your constant of variation. So if I'm looking at a table of values and I want to be able to tell whether or not it has a direct relationship or an inverse relationship or neither, because sometimes it's just a completely different type of relationship. These are just two examples of relationships. We need to find the k, all right? So in a direct relationship, let's solve for k. If we divide both sides by x, k is equal to y divided by x. If we, excuse me, if we solve for k in an inverse relationship, k is equal to y times x, or x times y. All right? And so if you're looking at a table of values and you want to know whether or not they have a direct relationship or an inverse relationship, then what we want to do is we want to take all the pairs of numbers and divide them and multiply them. If we divide them all and we get the same number every time, then they have a common k and it's a direct relationship. If we multiply the numbers every time and we get the same number every time, they have a common k and it's an inverse relationship. If we divide them and we multiply them and we get a different number every time, then it's neither a direct or an inverse relationship. So for example, let's say I have the following set of values. I've got an XY table, and it's got 0.212, 0.64, and 1.22. And I want to know whether it has a direct relationship, an inverse relationship, or neither. I'm just going to take my calculator, and I'm not going to overthink it. I'm just going to look and see, okay, these numbers are getting bigger, and these numbers are getting smaller. So it's not going to be a direct relationship. If it's going to be anything, it's going to be an inverse relationship. And so I want to try multiplying them and see if I get the same number every time. Just because this one is increasing and this one is decreasing does not make it an inverse relationship. But it does mean that it's not a direct relationship. So let's see, if I do 0.2 times 12, I get 2.4. If I do 0.6 times 4, I get 2.4. And if I do 2 times 1.2, I get 2.4. So because I multiplied them, my little pairs of numbers, and each time I got the same number, that means that this is, in fact, an inverse relationship. All right? And so that's how you can check and see whether a set of data is an inverse relationship or not. How do we actually use this? Well, they generally show up in word problems. A lot of times it's when we know the relationship is an inverse relationship. We have two sets of numbers, a set of numbers that we know works, and we're trying to solve for a different situation. You see that pop up a lot. So there's a couple of different ways that you can see these problems. So let's look at a couple of examples. If I have that y varies directly with x, y equals 7 when x equals 2, find y when x equals 8. All right, so there's a lot of information in this particular problem. The very first big one is the fact that y varies directly with x. If y varies directly with x, that means I know what the equation is going to be. We said that a direct relationship is always the equation y equals k times x. So this is what the equation is going to be. The only thing I need to solve for or to figure out for this, we said the only thing that is unique for every single problem is the k. So we need to find k. Well, if we go back over here and look at our notes, we said that in a direct relationship, k is always equal to y divided by x. So if we know that k is equal to y divided by x, that's where the second sentence comes in, because they give us an x and a y. Y is equal to 7 when x is equal to 2. So that means that k is equal to 7 divided by 2. So now I know that for this direct relationship, y is equal to 7/2 x. How is that useful? Well, now we can answer the question. The question says find y when x is equal to 8. So that means that I want to plug into the equation 7/2 times 8 and figure out what y is equal to. So this is going to be 8 divided by 2 is 4. 4 times 7 is 28. So y is equal to 28 when x is equal to 8. And that's how we use these problems. If it's an inverse problem, let's say that I have y varies inversely with x. Then we have that y equals 2 when x equals 4. Find y when x equals 1. All right. So if we have that as our situation, again, you break it down. What kind of relationship is it? That's the first thing we want to figure out. Y varies inversely. We said that the equation for inversely was y equals k over x. And folks, you just have to memorize that. That's an inverse relationship. That's going to be the equation. So this is my formula for an inverse relationship. Again, the only thing missing, k. So I got to remember that for an inverse relationship, we said that k was equal to x times y. So I need to find x and y. So x and y were 4 and 2. So k must be equal to 8, which means that y is equal to 8 over x. So if I want to answer the last question, find y when x equals 1, I'm just going to have to plug 1 in for x, and y must be equal to 8 when x is equal to 1. So that is an inverse and direct relationship. Now, we also know that in real life, very few things are quite that straightforward. Usually there's a lot more going on, and so we have what we call combined or joint variations. You can put them together. Sometimes we have two things, or three things that are in a relationship with one another. The one that stands out for me is in the gas laws. We know that temperature and pressure and volume are all connected to one another. The colder things are outside, the less volume it has. But as things get hotter, they expand. And when things expand, their pressure goes up. So temperature and pressure and volume are all very related to one another. But they're not just straight up inverse relationships. One of them has an inverse relationship, or two of them have an inverse relationship, and two of them have a direct relationship. So, you can have these things kind of combined together. What you have to pay attention to is just the words. Remember that in a direct relationship, it's k times the item, and that in an inverse relationship, it's k divided by the item. When we have combined variations, you still just have one k. You're only ever going to have one constant of variation, even if you have more than two variables in the problem. So there's lots of different ways that you could have some combined variations. So some examples. If we have the word jointly, let's say we have z varies jointly with x and y. Be aware that jointly is always an implied direct relationship. If it is not a direct relationship, then they will have to tell you specifically what other relationship it is. But if you just see the word jointly, that means that it is a direct relationship. In this particular phrase, we would write that as z is equal to k times x and y. So we just have more than one variable over here on this other side, but they're all being multiplied. It's k times. It's a direct relationship. Another example might be something like z varies jointly with x and y, and inversely with w. So if I'm reading this, z varies. One thing I get used to is that the varies is the equal sign. So z varies. Now jointly, we said was k times. So it's going to be k times x and y, but it's inversely with w. Inversely means k divided by, but it's going to be the same k. So that means that k is divided by w. So w goes down on the bottom. All of this ends up in one single equation. There's one k. Jointly was a direct relationship, so it was k times these two. Inversely was k divided by, that's an inverse relationship, so it's k divided by w. You can also have other relationships thrown in there. You could see something like z varies directly with x and inversely with the square of y. So if z varies directly with x and inversely with the square of y, again, I recognize that varies is my equal sign. So z varies directly is k times, so that'll be k times x. Inversely is k divided by, so that means I'm going to divide by something, and this time I just happen to be dividing by the square of y. So you can have other relationships thrown in there as well. When you're doing combined variation, what you want to always find first is your equation, because that's what we always need to start off with. It's like a formula. So you always want to find your formula first. In all of these problems, though, if we were going to use it to solve for something, we have to be able to find k, the constant of variation. So that means that they're going to have to give us one situation where we know where x, y, and z is equal to, or we know what x, y, w, and z is equal to. We're going to have one situation where we have all of the variables so that we can plug it in and solve for k. So when you're solving problems with variation, the first thing you want to do is find your equation. The second thing you're going to want to do is you're going to want to plug into your equation to solve for k. So you plug into your equation to solve for k. And then your third step is always going to be to solve for whatever it is that they're asking you to solve for, because usually they're going to say, find y when x is equal to this, or find z if x and y are equal to this. So solve for the variable in question. You can't do that until you know what k is, though. So again, you're going to have to be given some situation where you know all of the variables so you can plug in and solve for k.